Hi everyone, we're Mimicker, here to introduce all kinds of knowledge, even the stuff we didn't know about. Welcome to the deep dive. Okay, so think about paper. We use it constantly, right? Notebooks, packaging, you name it. And we always think, okay, trees, water, pulp mills.
That's the standard picture, absolutely.
But what if there was a paper, well, a material like paper that looks and feels like it, prints like it, but involves zero trees, and get this, zero water in its production?
Sounds pretty futuristic, doesn't it? But it's real. It's called stone paper.
Exactly. Stone paper, it's a fascinating thing. And today we're really going to, dig into it, our mission, unpack the sources, figure out what it is, how it's made, the good, the bad, and maybe why it hasn't quite taken over the world yet.
Yeah, it definitely challenges that traditional idea of paper.
Yeah.
And as we get into it, you'll see it's simple on the surface, but there's a lot underneath. Some real aha moments about sustainability and what that actually means in practice.
Okay, let's jump right in then. Segment 1. What is this stuff? Stone paper. I mean, the name makes you think of, I don't know, cave drawings. Is it actually rock?
Huh. Not quite like writing on a boulder, thankfully.
Yeah.
But yeah, the name points in the right direction. Stone paper is basically an alternative to traditional paper. And the key thing is no plant fibers, none at all.
No trees. Okay, so what's it made of then?
The main ingredient, like the vast majority, maybe 70 to 80%, is calcium carbonate.
Kikoshium.
Calcium carbonate,
Huh.
like limestone. Or marble. Exactly. And what's really neat is that it's often sourced from waste, the leftover bits from marble quarries, limestone cutting operations, or even recycled industrial calcium carbonate. So it's kind of upcycling waste material right from the start.
Okay, using waste stone, that sounds like a big plus right away. But stone dust doesn't just stick together to make a sheet of paper. What holds it all together? What's the binder?
Good point. Yeah, you need something to bind it. That's where polymer resin comes in. Usually it's about 20 to 30% polyethylene PE or sometimes polypropylene PP.
Ah, so it's plastic.
Essentially, yes, it's a composite material. Think of it as really fine stone powder held together in a plastic matrix. Very different from wood pulp paper with all its fibers.
Right, wood pulp has that fibrous texture. What does stone paper feel like?
It's incredibly smooth, almost silky. And it's denser than regular paper, noticeably so. Ranges from 1.0 to 1.6 grams per cubic centimeter. That density gives it a unique feel and adds to its durability. The stone particles are spread really evenly in the plastic, and then it's all pressed super thin.
Stone and plastic.
Yeah.
Okay, now this is where I got really curious reading the sources. The manufacturing. If there are no trees and, crucially, no water, how do they actually make it into sheets? What does that process look like?
This is maybe the most revolutionary part, especially for the environmental claims. They call it a physical dry process. And it means exactly that. No water used in the production at all.
No water, compared to traditional paper, which uses thousands of gallons.
Thousands. And no harsh bleaching chemicals either, like chlorine. Traditional paper often needs bleaching to get white. Stone paper doesn't.
Wow, zero water, zero bleach. That's fundamentally different. Okay, so walk us through it. How do they combine the stone and plastic?
Okay, so it starts with raw material prep. They take the calcium, carbonate the limestone or marble waste, and grind it down into an incredibly fine powder, like super fine, almost like flour. At the same time, they get the plastic resins ready.
Right, stone flour and plastic.
Then comes mixing and pelletizing. They mix that fine powder, the plastic resin, and maybe a few minor additives, things to block UV light or help it process smoothly. They blend it all together really well.
Okay.
Then this mixture is heated up, it melts, and they push it through something called an extruder to form these little uniform pellets, like tiny beads made of stone plastic mix. Industry calls it a master batch.
Little pellets. Got it. So those pellets are the key ingredient for the final sheet.
Exactly. Those pellets then go into the next stage, sheet forming and calendaring. They remelt the pellets and then force the molten material through a die, basically squeezing it out into a long, continuous, thin sheet.
Like making pasta, but with molten rock and plastic?
Sort of. And then to get it really thin and smooth, it goes through calendaring. That's like passing it between sets of highly polished, often heated rollers. It presses it down to the exact thickness and gives it that super smooth surface.
Okay.
Or sometimes they use a film blowing method, kind of like how they make plastic bags, blowing a bubble of the molten stuff to stretch it thin.
Interesting. Different ways to get that thin sheet.
Yeah. And then finally, the finishing stage. The sheets are cooled down, edges trimmed, cut to the right size. And here's another key thing. Because it's naturally waterproof, the plastic component makes it repel water, It usually doesn't need any extra coating or lamination for that property.
Ah, so that saves another step and more materials.
Precisely. So the whole dry process is very clean. No wastewater effluent like you get from pulp mills, no air pollution associated with pulping, and as we said, no toxic chemicals like chlorine. It's a very different environmental footprint at the manufacturing stage.
Okay, segment 2 then. Promises and pitfalls. We've touched on the manufacturing benefits. No water, no trees, no bleach. That sounds amazing environmentally. But what about performance? How does it actually stack up against regular paper in day-to-day use?
The advantages are pretty compelling, yeah, going beyond just the production side. Let's talk performance. First off, it is completely waterproof, like seriously waterproof.
You could actually dunk it.
You could literally hold a stone paper notebook under a running tap, pull it out, wipe it off, and the pages are fine. They won't disintegrate, get soggy, or warp like pulp paper would instantly. It's also incredibly tear-resistant because of the plastic component. Much harder to rip than regular paper.
Wow. Okay, waterproof and tear-resistant. That sounds useful.
Definitely. And that super smooth surface we talked about, it's fantastic for printing. Both inkjet and offset printing work really well, giving you sharp, clear images. It apparently holds ink well and is resistant to fading too.
So good print quality.
Yes. And because it doesn't absorb moisture from the air, it's dimensionally stable. It doesn't swell up or shrink when the humidity changes. So no warping or buckling.
Okay. So where would these properties be really useful?
Think about specific applications where those things matter. Maps for hiking or boating stuff that's going to get wet or handled roughly. Outdoor posters or signage that needs to survive rain and wind.
Right, makes sense.
Even things like labels for food products that go in the fridge or freezer where condensation is an issue for regular paper labels. Or durable menus for restaurants. Anything that needs to be tough and water resistant.
Okay, those are some solid niche uses. What about the cost? You mentioned the raw materials, waste stone, are cheap. Does that translate to cheaper paper?
Well, that's the interesting part. On the raw material cost side, yes, calcium carbonate from waste is much cheaper than virgin wood pulp. And the manufacturing process itself, being simpler and less energy intensive, should, in theory, be cheaper too. Less labor involved as well.
So it should be cheaper.
It should be.
Yeah.
But, and this leads us nicely into the disadvantages, it often isn't cheaper per sheet yet.
Ah, okay. So here comes the but. It sounded almost too good to be true. Waterproof, tear-proof, eco-friendly production. What's the catch? What are the downsides or limitations here?
And it's fascinating because the very things that make it strong, that stone-plastic blend, also create its biggest problems. Let's start with technological incompatibility. Big one.
Meaning?
Heat. Because it contains plastic, stone paper is not heat resistant. It has a relatively low melting point compared to, say, the temperatures inside a laser printer or a photocopier.
Oh, so you can't use it in a standard office laser printer.
Absolutely not. If you try, the heat from the fuser unit, the part that melts the toner onto the paper, will melt or deform the stone paper sheet. It can actually jam and seriously damage the printer. Costly repairs.
Okay, that's a huge limitation for office use. That rules out like 90% of everyday printing.
Easily. So it's fine for inkjet printers, which don't use heat in the same way, and for commercial offset printing. But for the average office or home user relying on laser printers, it's a non-starter.
Right. What else? Any other incompatibilities?
Well, remember how it's waterproof. That also means it's not breathable or absorbent at all.
Unlike regular paper, which soaks things up.
Exactly. So think about products where you need absorption. Paper towels, napkins, toilet paper, tissues. Stone paper is completely unsuitable for those. It just wouldn't work.
Makes sense. It repels water, doesn't absorb it.
And this non-breathability can be an issue in some packaging too. While it's great for keeping moisture out, it also traps moisture in. So for some fresh foods, like maybe certain fruits or baked goods that need to breathe a bit, stone paper packaging might actually trap too much moisture and affect the quality or shelf life.
Interesting trade-off there. Okay, so it's not good with heat, not absorbent. But the big question, the one that always comes up with eco-friendly materials, what happens at the end of its life? Is it recyclable? Biodegradable? This feels crucial.
This is probably the most critical point, and where a lot of the green claims get really complicated, and frankly, where there's a lot of misunderstanding.
Okay.
Because it's a plastic stone composite, stone paper cannot be recycled in the normal paper recycling stream.
Cannot at all.
Not with regular paper. Think about how paper recycling works.
Yeah.
They use water to break down the wood fibers into a pulp. Stone paper, being mostly mineral powder held together by plastic, doesn't break down in water like that. It just stays as pieces.
So it contaminates the paper recycling.
Exactly. If it gets mixed in, It acts like a contaminant.
Mm-hmm.
Doesn't pulp properly, it can mess up the consistency of the recycled paper batch, create imperfections, and the plastic component can even potentially gum up or damage the recycling machinery because it melts differently from paper fibers.
Wow. Okay. So you absolutely have to keep it separate. Can it be recycled at all then? Maybe with plastics?
Technically, yes, it could be recycled, but it needs to go into a specific plastic recycling stream, usually designated as #2HDPE, because it's a polyethylene binder.
Mm.
But even then, it's a filled plastic, meaning it has that high percentage of calcium carbonate filler. Not all plastic recycling facilities are equipped or willing to handle highly filled plastics like this.
So dedicated recycling is needed, and that's maybe not widely available.
Precisely. The infrastructure for collecting, sorting, and specifically recycling stone paper just isn't there on a large scale yet. Which means, in reality, its actual recycling rate is probably very low. Most of it likely ends up in landfill or incineration.
Okay, that's a major, major issue for its environmental credentials. What about biodegradability? The stone part makes you think maybe it breaks down naturally.
That's another common misconception. It is not biodegradable in the way that paper or other organic materials are. It won't break down in your compost bin or quickly decompose in a landfill.
So what happens to it?
It breaks down extremely slowly through a process called photodegradation. That means it needs prolonged exposure to strong UV light, like direct sunlight.
And what happens when it photodegrades? Does it disappear?
No. It basically breaks down into smaller and smaller pieces, tiny particles of the plastic resin, microplastics, and the calcium carbonate dust. It doesn't return to nature as harmless organic matter.
Microplastics.
Right.
So green production, yes, but end of life is a really significant challenge. It's essentially a plastic waste issue, albeit one mixed with stone powder.
That's a fair way to put it. The long-term fate of the material is a serious consideration that complicates the initial eco-friendly picture.
And what about those cost and scale issues we touched on? You said the raw materials are cheap, but the paper isn't necessarily. Why?
Yeah, that leads to the cost and scale limitations.
Yeah.
Even with cheap ingredients, the final cost per sheet or roll of stone paper is often still higher than traditional paper.
Why is that?
Mostly because it's still a relatively new industry. Production volumes are much smaller compared to the massive scale of the traditional paper industry. They haven't achieved the same economies of scale.
Okay.
Plus, the manufacturing requires specialized equipment, which means high initial investment costs for producers. And the whole supply chain distribution, marketing, getting it to consumers isn't nearly as developed or efficient as the centuries-old network for wood pulp paper.
So it's competing against a deeply entrenched, highly optimized global industry.
Exactly. Traditional paper is a mature commodity with incredibly competitive pricing due to massive scale and continuous optimization over decades, even centuries. Stone paper is, relatively speaking, the new kid on the block trying to carve out a space.
Okay, that makes a lot of sense. So let's move into segment 3, the path forward. We've got these amazing production benefits, some unique performance perks like waterproofing, but then these really significant hurdles. Heat sensitivity, the recycling nightmare, the lack of biodegradability, higher costs, scale issues. Given all that, why hasn't it become more widespread? What's holding it back from broader adoption?
It really boils down to a combination of those factors we just discussed, acting together. The application constraints are huge. Not being compatible with laser printers cuts off a massive potential market. Right there, most offices, schools, homes.
Yeah, the everyday printing market is basically closed off to it.
Right, and the non-absorbency rules out another huge category of paper products. Then, probably the biggest barrier, especially now with so much focus on circular economy, is the inadequate recycling infrastructure.
The fact that it contaminates paper streams and needs its own largely non-existent system.
Exactly. It's a logistical nightmare for waste management and recycling programs currently. You can't just toss it in the paper bin. You shouldn't toss it in the plastic bin unless you know exactly what type of plastic recycling facility it's going to and if they accept it. It creates confusion and contamination risk.
That alone would make municipalities and large companies hesitant to adopt it widely, I imagine.
Definitely. And tied into that is low market awareness or maybe misinformation. Many people hear stone paper and assume it's super green, maybe even biodegradable. They don't understand the plastic content or the recycling complexities.
So they might dispose of it improperly, making the problem worse?
Correct. There needs to be much better education for consumers and businesses about what it actually is and how to handle it at end of life.
Are there other factors, like policy or industry resistance?
Yes, both play a role. There's generally limited policy support. Unlike, say, incentives for electric vehicles or subsidies for renewable energy, stone paper doesn't typically benefit from strong government mandates, preferential purchasing policies, or funding for dedicated recycling infrastructure. Without that push, it's harder to scale up.
And the existing paper industry?
Well, there's industry path dependency. The traditional paper industry is massive, deeply invested in its existing pulp-based processes and infrastructure. And interestingly, they already use calcium carbonate
Wow.
as a filler. They add calcium carbonate to regular wood pulp paper to improve its brightness, opacity, and printability. So from their perspective, why switch entirely to a new composite material requiring totally new machinery and recycling systems when they're already incorporating the stone element to some extent?
Right, they're using it as an additive, not the primary component. No huge incentive for them to completely disrupt their own successful model for a product with so many unresolved issues.
Pretty much. Stone paper hasn't emerged as a clearly superior or more economical replacement for the bulk of their market.
Okay, so considering all these challenges, the practical limits, the recycling mess, the cost, the lack of infrastructure and policy support, the inertia of the existing industry, does stone paper actually have a realistic future? Is it just going to be a tiny niche forever, or is there potential for growth? Where does it fit?
I think it's really important to manage expectations. Stone paper is not going to be a universal replacement for wood pulp paper. It's just not suited for many high-volume applications.
Okay, so no stone toilet paper anytime soon.
Definitely not. But does it have potential? Absolutely. Significant potential for specialty applications. Niche markets where its unique strengths really shine and its weaknesses don't matter as much.
Like the examples you gave earlier, waterproof maps, outdoor signs.
Exactly. Those durable, waterproof notebooks for fieldwork or underwater use. Tear-resistant menus. High-quality labels for refrigerated or frozen goods. Maybe certain types of packaging where moisture barrier is paramount. Even some artistic applications where the smooth, durable surface is valued.
So focusing on where it offers a genuine, unique advantage.
Precisely. Its future success really hinges on tackling those key challenges, specifically within those niche contexts. First, reducing manufacturing costs and expanding production capacity to make it more price competitive against other specialty materials, not necessarily against cheap copy paper.
Okay, making it affordable for those specific jobs.
Second, and this is crucial, developing a dedicated recycling system, whether that's through improved sorting technology, specialized facilities that can handle calcium carbonate-filled plastics, or maybe even chemical recycling methods down the line. There needs to be a viable, scalable, end-of-life solution.
A closed loop, or at least a functional recycling path.
Yes. And third, really improving understanding. Educating designers, manufacturers, consumers, and waste managers about what stone paper is, what it's good for, and critically, how it needs to be handled and disposed of correctly.
So getting the cost right for its niche, solving the recycling puzzle, and making sure people actually understand it.
If those things happen, then yes, I think stone paper could become a really valuable complementary material. Not replacing paper wholesale, but sitting alongside traditional paper and recycled paper, offering a unique, durable, waterproof option for specific needs, and contributing to a wider portfolio of more sustainable material choices.
That makes sense. It's not the one-size-fits-all miracle paper, but a specialized tool in the materials toolbox.
That's a great way to put it.
Wow. Okay, what a fascinating dive that was. We started with this idea of paper literally made from, stone powder and plastic. We looked at how it's made, this really innovative dry process with no water or bleach, which sounds amazing.
Huge environmental plus on the production side.
Right. And then the performance, totally waterproof, super durable, great for printing in certain ways. But then came the reality checks.
The trade-offs.
Yeah, the heat sensitivity, locking it out of laser printers, the fact it doesn't breathe or absorb, and then the really big one, the recycling challenge. Not fitting into paper streams, needing its own system, and the whole microplastic issue if it just photodegrades, plus the cost and scale hurdles.
It really shows that green isn't always simple, doesn't it? There are layers.
Absolutely. It's a perfect example of how innovation, especially in materials, often involves these complex balances and trade-offs. It's not always a clear win-win.
Indeed. And I think what this whole exploration of stone paper really underscores is that when we talk about green technology or sustainable materials, we need to look at the entire life cycle, from sourcing the raw materials through manufacturing, use, and critically, end of life.
Not just focusing on one aspect, like waterless production.
Exactly. Being truly well-informed means appreciating both the exciting benefits and the real-world limitations or challenges. And maybe thinking about stone paper encourages all of us, listening today, to look a bit closer at the materials around us, to question labels, understand the nuances, and appreciate the complexities involved in trying to build a genuinely circular and sustainable economy.
A great final thought.
Yeah,
It's not about finding one perfect magic material, but understanding the spectrum of options and making informed choices based on the whole picture.
couldn't agree more. It's about finding the right material for the right application and understanding the full story behind it.
Thanks for tuning in to this deep dive. If you enjoyed our content, don't forget to like, subscribe, and turn on the notification bell.